Assalamualaikum. My name is Nafazila binti Osman, EA 18101 from session 2. So today I want to show about the kill simulation for instruction set for logical OR and AND. So first thing first, I want to check the error. So 0 error. Then I will debug. For the first data, I'm using instruction set move. And also for the second and the third. Then I will move the first data to register R0. It will be 43. The second data also I will move to R1, and the third data I will move to R2. Then next I'm using the logical OR, where I'm using two register. Register 1 I will OR with the R0 and store at R0. R1 43, R1 AC, R0 43. So in binary, 43 is 01000011, and AC 10101101. When I'm using the logical OR, 10 will become 1, 10 1, 01 become 1, 01 1, 00 become 0, 01 become 1, 101 01 1. So the binary for 1110 is F, and 1111 for F, 1110 for E. So when I run for logical OR and store to the register R0, then it will become EF. Next, for the logical ANDs, I will use two register. Register R2 will store to the register R0. R2 is 15 and R0 is EF. Then for the binary EF, 1110 1111. Binary for 15, 0001 0101. So when I'm using the logical AND, then 11 will become 1, 10 becomes 0, 11 0. 111 100 0 01 0 100 100 and 100. So the binary is 00000101. For the decimal 000 is 0, 0101 is 5. Then when I run for the logical ANDs, R2 will store to R0. Then by using logical ANDs, then it will become 5. Store at R0. So that's all from me about logical OR and ANDs. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Koyum from Group C, and I will present about the ORR instruction for okay, the function is for logical OR. The syntax for URL is ORRS, RD, RD, RM. For the tab is ORR, RD, and RM. For the condition flag, if S is specified, the OR instruction, they will update the N and Z flag. The C flag, they can update the C flag during the calculation of operand 2, and it doesn't affect the V flag. Okay, for the ORR truth table, the output will become true when one of the input is true. So if true false is true and true true is true. Just like that. Okay, thank you. That's all from me. Okay.
Hi, Assalamualaikum. So for today, I will be presenting EOR. The function of EOR is the logical exclusive OR. The syntax for URL is EOR as condition RTR and operand. But for the term, we don't have the operand. For the condition, if the S is specified, the EOR instruction will update the N and Z flag according to the result, and the calculation of operand 2 may affect the C flag, and the EOR will not affect in any way the V flag. So next is the circuit for EOR. So for A, it's RN, and for B, it's operand. So the out is the RD, the destination register. Okay, so it is similar to the XOR, the XOR logic gate. This is the truth table. So the truth table is if any one of the input is higher, then the output will be high. I think that's all. Thank you.
Good evening, everyone. So my name is Lim Jingbing, and today I will start my Group C presentation, my core processor Group C presentation. So today I will talk about BIC instruction, which is part of the logical instruction set of ARM assembly language. So its function is logical bitwise clear, and its syntax is in UAL, which is United Assembler Language, is BICS, RD, RD, RM. In DUM syntax is BIC, RD, RM, which RD is destination register, RM is memory register. Also, RD is where the data you want to root to. So RD. So after we perform BIC instruction, the RD will be the new RD will be the result of n operation of RD, the ORD, the old value of RD, and new and inverted value of RM. And in UAL, United Assembler Language, APSRN and APSRZ will be updated. And RD and RM are the row register. Next. So this is the digital circuit representation of BIC instruction. So BICS consists of 2 or 3 opcode. So RD, RM. So RD is destination register, and RM is memory register. So the new RD value will be the inverted value of RM with n operation of RD. So you can see from this equation, this formula. So BIC AB in truth table. So we can represent in discrete mathematics. So BIC AB, if A is true, B is false, then BIC AB is true. So if A is true, B is true, then BIC AB will be false. If A is false, B is false, then BIC AB will be false. If A is false, B is true, then BIC AB will be false.
Hello everyone, and
I'll be demonstrate for the instruction set ANDs, ORs, XOR, and so on, and Bic clear for our groups. My name is Carl, and let's start. So first, I have already debugged this program, and let's look at the first example for ANDs. And this is the value we'll plug in for R1, and this is the value we'll plug in for R2. So let's run it first, and the result will be displayed in R1. So please check out R1. Okay, so we get 1, 2, 3, 4, and 0, 0, 0, 0 for R1. Since the result is not 0 and negative, that's why the PSR here display is 0 and 0. So let's move on to the next example. Plug in value into R1 and plug in value into R2, and this is what we get. But since over here we put R2, right? So the result will be displayed in R2. And it started with a negative value, that's why the n over here is 1. So let's move to the next example. Plug in value into R1, R2, and we'll get the result at R2. And since for this example the result is 0, 0, 0, 0, that's why we all know that the 0 flag will get 1 as a result. And let's move to the next example for ORs. Plug in value into R3 and R4. So the result will display in R3. R3 is over here. And we get 1, 1, 1, 1, 1, 1. The result is same as the first example. We don't have any 0 or negative value. So it's get both 0 over here. Right. So next. The result will be displayed in R4 as well. So we get F. Since the result starts with F, right? Okay, then we all know that it's a negative value and the back. So n over here we get 1. Okay. Let's move to the next one. Okay, R3 plug in 0, 0, 0, 0, R4 is a 0, 0, 0, 0, and 0, 0, 0, 0. So we get a result in R4. Definitely we'll get result is 0, 0, 0, 0, and 0, 0, 0, 0, 0. And that's why over here we get 1 for 0 flag. So let's move on into next example. It's for EORs. Okay, plug in value into R5, plug in value into R6, and the result will display at R6. So we get 1, 1, 1, 1, 1, 1, 1, 1. So as I said just now, this result is not 0 and negative. That's why we get 0 for both of the flag. Right. So next example. Plug in value into R5, R6, and the result will be displayed in R6. Display in R6, right? So 1, 2, 3, go. Since started with F, then we can make a conclusion that it's a negative value. So the negative flag already run display 1 over here. Okay. And the next example for EOs. Plug in F, 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 and F, 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 and into R5 and R6. So we get the result at R6, and we get all 0 since it's an EOR, right? As my teammates already explained what's EOR about in the previous video. So we will get a 0 as well. That's why I update the flags as 1 over here, and Z stand for 0, and N stand for negative. So the last one is the Bic clear, right? F, 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 F into R1 and R2. 1, 1, 1, 1, 1, 1, 1, 1. So the result will display in R1, R2. Sorry. So let's see what's the result. Okay, we'll get 0, 0, 0, 0, 0, and the N flag and the Z flags is shown 1 over here. So that's all for our video, and we hope you understand what we are trying to explain about. Thank you very much.